Find the exponential function that passes through the points 1, 3, and 2, 9. They give you 4 functions. There are several ways to figure out a problem like this. When I first looked at this warm-up today, because I don't make these up, I get them off USA Test Prep. We've been working on sequences. So I saw it as a sequence, and I was like, okay, the first term is 3. The second term is 9. How do you get from 3 to 9? So the R value is 3. They are tripling. Okay, that's the way I looked at it. I saw that they were tripling. Another way that you could have looked at it is we have y equals 3 to the x, right? Well, when we're given 2 points, aren't we given 2 x values? The first x value is 1, so I'm going to replace the x with 1, and the second x value is 2. Well, what is 3 to the first? 3. What is 3 to the second? 9. So that's another way you could have looked at it. And then the last way you could have done it is if you would have graphed all of them one at a time, when you would have gotten to 3 to the x power. Okay, and then when you look at the table of 3 to the x power, doesn't it contain those 2 points, 1, 3, and 2, 9? And none of the other ones would have contained those 2 points. So that's why D is correct. Does that make sense? Okay, now turn in your packets to page 7. Turn in your packets to page 7. All right, page 7. Find a bank account balance if it starts with $100, has an annual rate of 4%, and the money left in the account for 12 years. Okay, this is exponential. In Unit 4A, we learned the equation of an exponential function. It's y equals a times b to the x power. Okay, that is the equation for an exponential function. Kind of like for a linear function, it's y equals what? Mx plus b. And for a quadratic function, it's y equals parabola, just y equals x squared. Or in standard form, y equals ax squared plus bx plus c. Yeah. Okay, so y equals, what number from this word problem will we plug in for a, for the starting value? 100. Okay, but this is probably what you don't remember from Unit 4A. I taught you another equation that's just a variation of this one, and it is to be used anytime you're given a percentage. In the b place, you put 1 plus or minus r. So is this a growth or a decay? A growth, because you're starting with 100, but then you're making money. You're making 4% of what's in your account. So since it's a growth, you do 1 plus. And then how do we write that 4%? 0.04, and then to the what power? 12th power, because x is time, and it's a 12-year period. Now all you have to do is type that in to see how much money will be in that account after 12 years. Does it round to 11? 10 cents. Oops, I wrote 11 anyway. $160.10. So really in those 12 years you only made how much money? $60.10. Well, that's how bank accounts work. They don't really have high interest rates, so even if you leave your money in the like a savings account, it doesn't make that much. You're better if you're trying to make money to do like stocks, but they're riskier because you could lose money, whereas in a savings account you can't lose money. Right, but still in a bank account they don't have that high of interest rates. Well, it just sits there, and when your money sits in a bank account, it does draw interest, but very little. So like I have X amount of dollars sitting in my savings account right now, so it's making money, just not that much. Right, it's more than they originally were given because it's accumulated interest. Like you may have heard a statement before, like when somebody wins a lottery, they can live off the interest because when you win the lottery, it's a very large amount. So if you put that large amount in the bank account, the interest it draws is quite a bit of money, and you can live just off the interest money and never touch the original winnings if you live right. Now, if you all of a sudden start living like a spectacular life, yeah, then you might not be able to live off the interest. All right. Number 2. In 1985, there were 285 cell phone subscribers, or users is what that means, in the small town of Centerville. Remember that this is 1985, where people didn't really have cell phones at all. Only the richest, and I don't mean anybody you know. I mean like the richest of the rich had cell phones at this point. Okay? The number of subscribers increased by 75% per year after 1985. How many cell phone users were there in Centerville in 1994? So Y equals 285, right? It's a growth, so it'll be 1 plus, and then the rate is 75%. And then after how many years? 9. From 1985 to 1994 is a 9-year period. So in those 9 years, how many cell phone users did that grow to? Right. And but remember guys, these are people, so since it's 0.99, shouldn't we just go ahead and round that up to 2 because people are whole numbers? And I don't know how accurate this number is, but as far as the scenario, that's accurate. From 1985 to 1994, the cell phone user population jumped a lot. It would have been a very steep curve because it grew fast, because phones became affordable. The cell phones became affordable. All right, number 3. Yes? 3. Bacteria can multiply at an alarming rate when each bacteria splits into 2 new cells, thus doubling. If we start with only 1 bacteria, which can double every hour, how many bacteria will we have by the end of 1 day? Drake, okay, Drake, you're right, but let's go over it. What is the A value? 1, because it says start with only 1 bacteria. Now, for this particular word problem, there's no percentage, so you're not having to use that 1 plus or minus R. How is it growing? Right, it's doubling, so all you have to do in the B place is put a 2 for doubling. This is the tricky part that gets most people. What do we put for time? Right. Most people that get this wrong put 1 for 1 day, but it's doubling every hour. So at the end of that day, isn't it going to have doubled 24 times? And so that's how Drake got that 16,770,216. All right, number 4 we did yesterday. Why don't you attempt it by yourself and see if you can remember how to do it from yesterday. Do not look back, just attempt it. Okay. Number 4, each year the local country club sponsors a tennis tournament. Play starts with 128 participants. During each round, half of those players are eliminated. How many players will there be after 5 rounds? 4. All right, number 5. The population of Winnemucca, Nevada can be modeled by P equals 6,191 people times 1.04 to the T power, where T represents the number of years since 1990. What was the population in 1990? Sure you do. Right. No, look. No, listen, because all they're wanting to know is what was the population in 1990, which is the original population when they started the study. Shh, y'all. It's not that big of a deal. Okay. think about it. It says T is the number of years since 1990. So they started looking at this town in 1990, and at that time, this was the population because that's what they put in as their starting value. So that was the population. Now, the harder question is this one. Not really harder, but by what % did the population increase by each year? No, you literally, you don't have to type in anything. You just have to look at the equation and know. I don't think I've heard it yet. What? No. Okay, look. Look. Think about it. If this became 1.04, doesn't that mean originally it was 1 plus 0.04? So isn't 0.04 in the R place, which represents 4% growth? All right, number 6. You have inherited land that was purchased for $30,000 in 1960. The value of the land increased by approximately 5% per year. What is the approximate value of the land in 2011? So Y equals, what is the A value? And then is it 1 plus or 1 minus? Right, because the land value is increasing. By what %? To the what power? 51. Because from 1960 to 2011 is 51 years, and that's how much money that the land is now worth. Right. And 9 cents. All right. Number 7. During normal breathing, about 12% of the air in the lungs is replaced after one breath. Right. What? We'd have to Google it. I didn't make up the worksheet, so I'm not sure how factual that is. All right, during normal breathing, about 12% of the air in the lungs is replaced after one breath. Write an exponential decay model for the amount of original air left in the lungs if the initial amount of air in the lungs is 500 milliliters. How much of the original air is present after 240 breaths? So Y equals. Okay. And then to the what power? Right. Okay, but tell me what that number means. Okay, but like, what is at the end of that number on the calculator? Which is scientific notation. Is it a negative number or positive? Okay, so that means it's a very small number, close to 0. So we're just going to put 0. 0 of the original air is present after 240 breaths. Okay, now turn to page 8. Shh, everybody turn to page 8. Number 8. Shh. An adult takes 400 milligrams of ibuprofen. Each hour, the amount of ibuprofen in the person's system decreases by about 29%. How much ibuprofen is left after 6 hours? So Y equals 400, right? It's minus because decreases to the what power? And so Y equals, right, 51.2 milligrams. Now, you know how like when you pick up a medicine bottle, it'll tell you like, do not take more than this in this amount of hours? Well, they don't just make up those numbers. They know how fast that medicine leaves your system and when it's safe for you to put more in your system. And that is because of equations like this. That's how they figure it out. Well, I think those are just like 2 a day, right? Flintstone gummies. Number 9, you deposit $1,600 in a bank account. Find the balance after 3 years for each of the following situations. We're going to start with C because it's the easiest, so jump down to C. Y equals, what is the starting value? Right. Is it a growth or a decay? Right. They're paying you 4% interest, so you're making money on the money in your account. So 1 plus what? And then this is compounded yearly, which means once a year for how many years? 3. Now calculate that and see how much money will be in that account after 3 years. Whoa, whoa, whoa. $1,799.78. If you stop after the hundreds with money. Okay, now just pay attention for a second for A, and then I'm going to let you try B by yourself. Just pay attention. Okay, so we're still using this same scenario where we're still depositing $1,600 in that account. And it's still paying interest, so you're still making money on that $1,600, but this time at a rate of 2.5%. Okay, look, this is where it gets different. 0.025. However, it's not compounded yearly. It's compounded monthly, which means how many times are they going to compound it in a year? So you divide your rate by 12, and then up here beside the 3, it's not just going to be compounded 3 times because it's not once per year. It's going to be compounded 3 times, 12 times, which is 36 times total. Does that make sense? Now figure out how much money that would be and then try B by yourself. Okay, try B by yourself. Nobody yell out any answers. Four times a year. There's 4 quarters in a year. January, February, March. No, it's 4. You'll use 4s this time. Oh, you mean this? Yes, this would be a 12, yeah. Okay, for this one, since it's compounded quarterly, that's 4 times a year. So you just divide your rate by 4 and you multiply your time period by 4. Because if it goes on for 3 years, 4 times a year, and that's going to end up being compounded 12 total times, which is what that 3 times 4 will make. And then what amount of money is in the account after that? I didn't get that. 0.05. Look, did you type in your rate correctly? 0.017? All right, number 10, you buy a new computer for $2,100. The computer decreases by 50% annually. When will the computer have a value of $600? What's my A value this time? Right, that's what the computer was originally, the starting value. It's decreasing, so that would be 1 minus 50%, which is 0.50. But look at what the question is. When, which means we have no idea what to plug in for x, because x is time, and we don't know when. So we graph it and look for what? Well, right, you look for 600 in the y place. So go to your calculator and go to y equals and type that in. So y equals 2,100 times 1 minus 0.50 to the x power. It was 2,100 first, right? Okay, now I'm looking for when the computer is worth $600. Well, after 1 year, it's still worth a little bit over 1,000, 1,050. By 2 years, it's worth 525, so lower. So doesn't it occur sometime between year 1 and year 2? So you could just write between 1 and 2 years. Now, when you get to Algebra 2, you're going to learn about logarithms, and logarithms will allow you to solve for x to know exactly what the number is. Junior year. You drink a beverage with 120 milligrams of caffeine. Each hour, the caffeine in your system decreases by about 12%. How long until you have 10 milligrams of caffeine? So, y equals, you start off with 120 milligrams, and then each hour it's decreasing, so 1 minus 12%, which is 0.12, but it says how long, which lets me know we don't know the time period. It's unknown, so that 10 must be the y value. So you will graph this and figure out which x value has a y value close to 10. So y equals, what's the first one, 120? That's what you started with, times 1 minus what? To the x power. And you're looking for when 10 are left. Well, obviously it's past 11 hours because at 11 hours, 29 is still left. So we'll say between 19 and 20. Yeah. I do not, they must have transferred from a different school system. Because the only way, like even our students here who are like smart in math, they're not in geometry as freshmen, they're in accelerated algebra 1/geometry. So like first semester, they learned algebra 1, and part of second semester they learned algebra 1, but right now they're already taking geometry. And then next year they'll finish geometry and they'll start algebra 2. And then the next year they'll take pre-calc, and then the next year they'll take calc. Now, for those of you who didn't start on that program, you are still able to get to calculus if you want, but you would have to double up your junior year and take 2 maths. You would have to take algebra 2 and pre-calc your junior year. And I already talked to those people this year that I feel like are going to be eligible for that. Like those are people who are making an A in here, they make an A in geometry, and if they want to go to calculus, they'll take algebra 2 and pre-calc their junior year. I didn't? Well, as x equals what? Approximately what? 19 hours or between 19 and 20 hours? All right, number 12. The foundation of your house has about 1,200 termites. The termites, you know, they're the things that eat wood. The termites grow at a rate of about 2.4% per day. How long until those termites double? So y equals, what's the starting value? Right? And then is it a growth or a decay? Growth. It has the word grow. So 1 plus, what's the percent as a decimal? 0.024. Now remember, for those of you who struggle writing it like this, if you just type in 2.4 divided by 100, it'll tell you this. You always just divide it by 100 to remove the percent sign. And then it says how long, which lets me know I don't know the time period. So what else do I have to plug in? Well, we don't know the x. Okay, so what does that mean? Okay, which it will, right, whenever it reaches 2,400, which is when 1,200 is doubled. Now you will graph that and figure out the x value that it would take to be 2,400 in the y place. Between 29 and 30. And that is days, right? Okay, now we have 4 more to do back on page 4, so go back to page 4. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . All right, number 7. You open a savings account with $350 that you have saved. The bank offers 2.8% simple interest each year. How much money will you have in your account after 10 years? Oops, I don't know what happened. Okay, go ahead and start that one by yourself while my computer does something. Y equals, what did you put for your A value? And then is it a growth or a decay? So 1 plus, what's the percent? Right? And then after 10 years. And so what is in your savings account after 10 years? No, it's not. Savings accounts don't pay much money. That's why if you really want to make money on your money, you have to invest in like stocks. But stocks are risky. Because one day a stock could be worth a lot of money and the next day it could plummet. You lose that money. Yeah, stocks are risky. Like I have some through, a couple more at least. A bicyclist is training for a race. During her first week of training, she rides 12 miles. So it starts with 12. She increases the length of her ride by 20%. So 1 plus 0.20. Write the explicit formula to represent the length of her bike ride after N weeks. They don't tell you a time period. They just say after N weeks. So that's all you're able to do with this problem. You can't actually solve it for anything. Number 9. Your grandmother owns a rare antique lamp that is valued at $5,000. An antique dealer that the lamp says that the lamp will gain value at a rate of 10% each year. In how many years will it be worth $6,655? So it would be $5,000 would be its starting value, and then it's gaining value, so 1 plus 0.10. But in how many years means we don't know the time period. We're trying to figure out how many years it will take to be worth that. So what do? You replace the y with this number, and then you graph it and go to the table and see which x value has a y value close to that. And you get, and it's actually exactly, not approximately, it's an exact number of years. Is everybody typing it in? You're looking for when it will be worth $6,655. I got 3. All right, last one. The number of dandelions in your yard spread following a geometric sequence each day. On the 3rd day, there are 156. On the 6th day, there are 1,248. They want to know how many there will be after 9 days. So what do you have to do? What'd you get? Okay, but think if you first need to check and make sure that's the right number, because what's 156 times 8? It's not 8 because it's 2. 156 times 2 is 312. 312 times 2 is 624. And 624 times 2 is that. So 2 is the R value. Right, you should end up with this. Yeah, I get what you're saying when you divide it by 8, but that would be only good if you were trying to fill in for 1 blank. You're trying to fill in 2. You got that one? Oh. Okay, you may switch out. I'd have to look at it to see exactly how you got it to work